So 7.2a, complex, turn my little light on, and irrational zeros. Okay, find all the zeros. So same kind of process as yesterday. The only difference is we're going to get to a point where we're either going to have a radical, that would be your irrational, or a complex zero. Now, not all radicals are irrational. Most often you'll see radical 2 or radical 3. But we may have those left in our answers. So find all the zeros of f of x equals x to the third plus 3x squared plus 2x plus 6. How many answers am I going to have? 3. Not too bad, right? So I'm going to see, is my calculator going to work? I hope it is. I'm going to graph this on the calculator. And yes, there's a reason why I'm doing it on the calculator and not on Desmos. Oops. Plus 3x squared plus 2x plus 6. Okay, so what we're going to do first is come up with our list of possible rational roots. You ready? So factors of the constant. What's my constant? 6. So I have 1, 2, 3, 6. Factors of the leading coefficient. We have, it's just 1, right? I like it when it's 1 because then we don't have any fractions on our list of possibilities, right? So our possible roots are 1, 2, 3, 6, and the negative of all those as well. So how many numbers are on my list? 8. Okay. Now, I'm going to look at the graph, and this could be the way it is on a test where you have a picture of a graph, but you don't have the little mouse where you can actually scroll over and see, like on Desmos, where it pops up the value for you. So I'm going to look at this graph. It looks like there's only one x-intercept, doesn't it? But isn't it a third degree? What does that mean? It means there's one real zero. The other two are going to be imaginary. So this is the only one I'm going to be able to get using synthetic division. What does it look like that value is? -3. So why don't we start with -3 as our box number? Thankful I looked at the graph because using my logic, I would have gone through 1, -1, 2, -2 before and 3 before I got to -3. What are my numbers across? 1, 3, 2, and 6. All right, let's do our long division. Bring down the 1. -3 times 1 is -3. That gets me 0. -3 times 0 is 0. 2. -6. Thank you. And 0. So what do I have? I had x to the third. Now I have x to the second plus 2. So in my 3 answers, one of my answers is -3. Yeah? Okay. So I'm left with x squared plus 2. I could factor. Not very well, could I? Kind of tricky, huh? When I have something basic like that, let's just set it equal to 0 and see what we get. How do I get x by itself? Subtract 2. That gives me what? X squared equals -2. And now what? Square root both sides, remembering plus and minus. Now, the square root of -2, we cannot leave a negative inside the square root. We talked about this a little bit earlier. I have to take out an I, and then the 2 is the only thing left in there. So I said that our other two roots would be imaginary. Here's our other two roots. There's the I for imaginary. So my other 2 would be plus and minus I radical 2. That wasn't too bad, yeah? We all know that sometimes I's get a little bit more confusing, a little bit more in depth, but that wasn't too bad. So let's try this guy. Is this enough page for me? Hopefully I have enough paper here. F of x is equal to x to the 5th minus 4x to the 4th plus 4x to the 3rd plus 10x squared minus 13x minus 14. Franken, why are you going crazy? That's what you're thinking, right? So let me graph this. While I'm graphing this, why don't you come up with your list of possible roots? Okay? X to the 5th minus 4x to the 4th plus 4x to the 3rd plus 10x squared minus 13x minus 14. What's your list of possibilities? Thankful for that leading coefficient of 1 again, right? So we have 1, 2, 7, 14. Yeah? Are you okay that I didn't take the time to do the constant? You can come up with that on your own at this point. Now, look at my graph. Kind of hard to see, isn't it? Do you want me to try and zoom in a little bit? Zoom, what do I want? I think I want zoom decimal. Give it a minute. There it is, zoomed in a little bit. Now, something I notice is that there is an x-intercept over here. Yes? There's also an x-intercept over there, but those two x-intercepts look different, don't they? One of them is kind of like a bouncing x-intercept. It hits the x-axis and bounces off. The other one is completely crossing through. When we have an x-intercept that bounces off like that, we have something that has a multiplicity. So, if I can estimate what that intercept is, it should work 2 times for me. Does that make sense? If it's just crossing like this, it's only going to work once. But if it's doing that bounce thing, it's going to work twice for me. So what should we guess that one is? -1? Let's check. So -1. And then 1, -4, 4, 10, -13, and -14. Keeping in mind you have to fill placeholders if they're needed. Bring down my 1. That would be -1, -5, 5, 9, -9, 1, -1, -14, 14, 0. Yay! So how many answers am I looking for? 5. And -1 is one of those 5. Now, because it had that bouncing quality to it, what do I mean when I say it should work twice? Well, I just took the 5th degree down to x to the 4th minus 5x to the 3rd plus 9x squared plus 1x minus 14. I should be able to use -1 as my box number again to get that down to a 3rd degree. That's what it means by working twice. So let's do that. Let's see. 1, -1, -6, 6, 15, -15, -14, 14, 0. It works twice. So on my zeros, I'm going to say -1 has a multiplicity of 2. So it's 2 of my 5 answers. Does that make sense? Okay. So I'm now down to what? 1x to the third minus 6x to the second plus 15x minus 14. Let's go back to my picture and see what do we think this point is that it's crossing at. 2. Let's try 2. So let's see, I'm running out of room here. But if I try 2 as my box number, I'm going to have 1, negative 6, 15, and negative 14. Bring down my 1. 2 times 1 is 2. Negative 6 plus 2 is negative 4. 2 times negative 4 is negative 8. 15 minus 8 is positive 7. 2 times 7 is 14. And there's my 0. So 2 is another of my answers. So? Do you follow what I've been doing so far? Okay. So I'm now down to what? X squared minus 4x plus 7. Can I snowflake that? This would be technically equals 0. Is there a snowflake that would have 7 and negative 4? Not going to work, is it? So what do I have to do if I can't snowflake? X equals negative b plus or minus, you remember that? Plus or minus the square root. Okay, so negative b plus or minus the square root of b squared minus 4ac all over 2a. That's my quadratic formula. That's what I have to use if I can't factor. Okay? So in my equation here, A is 1, B is negative 4, and C is 7. Yeah? So, negative B, well, B is negative and there's a negative in the formula. Does that mean I put 1 negative or 2? There's the negative from the formula. I'm going to plug negative 4 in right here, so it's going to end up turning positive. Plus or minus the square root of negative 4 squared minus 4 times 1 times 7 all over 2 times 1. Okay, let's do some simplifying. Negative times negative 4 gives me a positive 4. Plus or minus. This part I like doing on my calculator, so I can get it all done at once. So let's see, parentheses, negative 4 squared minus 4 times 1 times 7 is negative 12, all over 2. Still a little ugly, isn't it? So I'm going to keep going. Now, whenever I have something that, if this is going to keep its radical, that means I'm not going to end up with nice numbers. I'm going to end up with a radical in my answer, right? I need to split this up into 2 fractions. So I'm going to call this 4 over 2. That's my first fraction. Plus or minus, this is my second fraction. Radical negative 12 over 2. That way I can simplify them each individually. And that makes my life a little bit easier. You okay with what I'm doing so far? See if I can finish the page down here. 4 over 2 reduces to what? 2 over 1. So that's just 2. Plus or minus, let's see what this is going to be. There's a 2 on the bottom. The negative means I'm going to have an I. And how do I simplify radical 12? I have to draw a tree for 12, right? 2 and 6, 2 and 3. What's going to come out? A 2. Where does the 2 go with regards to the I? It usually goes in front of the I, and then the radical comes after, and the 3 is left inside, right? So far, 4 over 2 plus or minus radical negative 12 over 2 has simplified to this. Can I simplify any further? I can cancel out those 2's, can't I? So I have 2 plus or minus what? I radical 3. How many answers is that? 2 answers, right? It's 2 plus IRAD 3 and 2 minus IRAD 3. So if I go up to my list here, I had negative 1 that had a multiplicity of 2. I had 2, and now I can add to that list 2 plus and minus I radical 3. So what's the part of this that makes it different than yesterday? That's the only thing that's different. So you're going to have to work on that simplifying and practicing that simplifying a little bit more. Does that make sense? Okay. Let's see. How am I doing on time? I think I have enough time for one more example. Okay. I'd like to do one more example with you. The last example I may save and just include in tomorrow's notes. Okay. So let's do one more together. F of x is equal to 2x to the 4th plus 9x to the 3rd plus 5x squared plus 3x minus 4. Okay, you ready? Let's see. Why don't you come up with the list of possibilities while I work on graphing? Oops. So what's my list of possibilities? Obviously, it's going to be 1, 2, 4, 1 over 2, and then 2 over 2 and 4 over 2 are duplicates. So that's my list, right? Okay. So let's look at the graph. That is a funky looking graph, isn't it? You can't hardly even see it. There we go. Now you can see it a little bit better. This one does not look like it's crossing at a nice number. It looks like it's crossing between 0 and 1. So that could mean it's 1/2, right? This one looks a little bit easier to guess. I would guess that's negative 1, 2, 3, 4. So why don't we start off with negative 4? Neither of those, by the way, were a bounce, right? Sorry, the glare there is bad. Neither of those were a bounce, so we don't have any of those. So negative 4, I have 2, 9, 5, 3, and negative 4. Bring down my 2, negative 8, 1, negative 4, 1, negative 4, negative 1, positive 4, 0. So how many answers am I looking for? 4, and I just found one of them is negative 4. Okay, I'm now down to what degree? So I have 2x to the 3rd plus 1x squared plus 1x minus 1, and I got to keep going. What was the other point on my graph that looked reasonable? 1/2. Let's try 1/2 and see if we get that other one. Because I don't think I can use grouping here. So I think I have to try 1/2. So again, I'm going to use my x to the 3rd coefficients. Use that fraction button on your calculator if you need to. Oops, that's a 2. 2 times 1/2 is 1. 1 plus 1 is 2. 2 times 1/2 is 1. 1 plus 1 is 2. 2 times 1/2 is 1. Negative 1 plus 1 is 0. Our second answer is 1/2. We got 2 more answers to get. I'm now at 2x squared plus 2x plus 2 equals 0. What do you notice about those? You can take out a 2, right? Or divide by 2. Let's divide everything by 2. That way it just disappears. That gives me x squared plus x plus 1 equals 0 divided by 2 is 0. Can I factor that? Are there two numbers that will multiply to get 1 and add to get 1 also? No. So I'm going to have to use quadratic formula. So what's my A value? 1. B is also 1, and C is also 1. So let's see, negative B plus or minus the square root of B squared minus 4AC all over 2A. Negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1. That's the square root of negative 3 all over 2 times 1, which is 2. Now, what did I say before? If you have the radical stuck in your answer, you have to split it up. So that would be negative 1 over 2 plus or minus square root of negative 3 over 2. And what am I going to call that? Square root of negative 3. Can't leave the negative under there. I radical 3. So my other two answers are negative 1/2 plus and minus I radical 3 over 2. Now again, because they're imaginary, if I look at the graph, you don't actually see them crossing our x-axis. Okay, so? All right, I'm going to stop there just for time's sake. I do have another example I can do tomorrow if we still need some more practice on this. But you can go ahead and get started on your homework. It is posted on Google Classroom. Happy studying.